Thank you, thank you. It's wonderful being here again. And as Julian told you, I'm going to be talking a little bit about how we're implementing SSR on a very large application that is extremely dynamic. It's mostly a painful story of things that we realize when we're doing this, and a lot of these kind of details that you don't really think about it. They might be obvious in the end, but it's kind of important to keep them in mind if you're actually going to be implementing SSR in any larger scale. So, before I actually talk about that, maybe I just do a tiny recap of why this would be important, why this actually makes sense, and it's very simple. SSR will most likely make your application much faster, and that's going to be better for your first user experience, and also going to be a lot easier for search engines to find you, so you'll end up on Google more often and get more users. But when I mean that it's going to be faster, I essentially mean for the first user experience. And when you have a normal client-side render application, this is more or less what it looks like. You know, maybe you load an HTML with a loading spinner on it, then you have a moment where you actually build the application, and you might build it by different parts until eventually the application completely renders. Even if you work on trying to make this much faster, you can only do so much. So here you have a more optimized version of an application where you've essentially reduced the amount of waiting time by preloading and essentially configuring certain things to render faster on the page. But of course, just having some type of SSR, just kind of the basic doing something like an app shell pattern, is already going to be a pretty large improvement, as you're already going to be loading a lot of the content that already needs to be there, and you'll know in advance certain lazy pieces that might require being loaded. And of course, an optimized version is just completely different. Like, the experience feels much more instant, and that's kind of where you want to go. Of course, this doesn't mean you have to implement it the same way for your whole application, and you can implement it in parts and essentially continuously migrate towards an implementation that uses more use cases. So, just kind of re-showing that, you have a basic client-side rendered application, a server-side rendered client-side rendered that's a little bit more optimized and actually performant, and we keep going on that, essentially doing something like a shell pattern, an app shell, and then finally a fully optimized SSR application. Kind of what I'm talking about here is that process of getting to have a much faster application through SSR. But maybe your application is too complicated. Maybe it's too dynamic. Maybe you have other reasons why this isn't going to work for you. That's a common thing that you hear, that it's not really going to work because, there's too many features that are just too dynamic in that. This is kind of a good use case that you can see where this is a very dynamic application with multiple different widgets that gets configured for multiple different things. And yes, we are able to actually server-side render it. It's just a question of what's it worth for your final user. Like, is it worth it to make this application faster? Is a question of how much it actually helps out your final user and how bad your user experience is without this initial loading period. So it's essentially a trade-off with that complexity. With that being said, as Julian has already introduced me, my name is Christopher Holder, and I'm essentially going to be talking about some of the details on how you implement SSR in a larger, more complicated application, and some of just kind of the underlying topics that you might want to think about. That means that first I'm going to talk a little bit about execution context, so the things that actually wrap that, then the runtime itself and how these different runtimes actually interact with each other, talking then about pending tasks, which, at least to me, is a very painful topic, and finally talking about hydration, how you actually debug that process. First, execution context. All right? So, I don't know how often we actually think about execution context in Angular, except kind of in the level of different routes. But there is kind of a clear difference when it actually comes to SSR, and that is that they're very different execution context. You have what's going to run on your actual device, on your browser, and then you have what is actually rendering it on the server. Now, that means that also the lifetime of the application is completely different in those two use cases. One of them, you have an application that you get an HTML, you render it, the user interacts, and there's multiple things going on, compared to a single time that the application runs, and it delivers something valuable that then connects onto the user, and then the rest of the experience is on a fully different context. This is a little misleading, though, because it makes it look like each one of these applications or each one of these renders happens kind of in its own isolated thing. Reality is they all kind of happen synchronously on the same thread, usually. So what that actually means is that anything that is running on that is going to affect the other renders. As long as you have anything synchronous running inside of that, asynchronous running in the application, you're essentially going to be running multiple times the render concurrently or in parallel. And that's kind of the first topic. Global is not your friend. The global scope is really not something that you should be using inside of Node applications. Every time you do this, you essentially create a risk that it's somehow going to affect another part of your application and that it is going to either crash it or provoke some other different change that you're not expecting. Apart from that, you often have different type of APIs. If you have this, especially inside of Node, where you store something inside of the global state, right? And you have two applications running in parallel, you can't actually tell which of these are actually affecting them. And that is kind of a big issue. But then you have the additional problem with this, which is the actual runtime. Well, they're completely different runtimes. You know, we have an actual browser runtime, and essentially that has like one set of like platform APIs, and then you have like the server side one. And yes, sure, most of us that do some type of server side rendering work with Node. However, that is, of course, not our only option, and more there are other options that have their own advantages. For example, using Bun, Dino, or Cloudflare workers. Cloudflare workers, for example, is becoming more and more popular and actually allows you to like deploy a single function that will execute to render your application. But it also means that you're restricting the APIs that are going to load even more. So now that we have this concept of different APIs that are available and that I've just told you that you should not be using a global, you can see how something as simple as this is going to go wrong. Because what document are you talking about? Of course, the server, there's obviously no document. It is, of course, not an API that is available in Node. And even if it was, what render would you be referring to? As it can both be running in parallel. And that is where the beautiful Domino comes in. Domino is, as the name implies, a DOM inside of Node. It's a little bit more than a DOM inside of Node. It is essentially a factory that creates these browsers inside of Node that allows you to actually render your application and interact with these browser APIs inside a single context for this render. Now, there is a little bit more to that, and it's also important to consider that they actually chose to implement it in a way that is more performant instead of just more compliant to all of the different browser standards, which means that there are multiple APIs that you don't have available on just SSR normal rendering. And because of this, you have to actually start getting very used to using dependency injection, because it really is your best friend in this context, because there's so many different contexts and it allows you to essentially get the right version that you actually want for everything. Same example here, but instead of getting the document, we're going to go ahead and use dependency injection to pull out the document and actually read it right from there. I will mention that there is also some cases in which you can't modify it directly. However, those are kind of specific use cases, and usually you can go ahead and directly write to the document there. Now, that is for the basic part. Of course, there's a lot more to it. And therefore, I kind of want to introduce a little bit more of platform API shimming, because as I told you, you don't have all the APIs available. So, just kind of out of the box, you'll have the default. You'll be able to get the document. From there, you can get a window and an element, and you can kind of use the same way that you've been using it in Angular in general. But you're not going to have everything. You're not going to have cookies. You're not going to have local storage. You're not going to have geolocation, navigator, and a couple of additional features. And the question then goes, how do you use them? If your application is already using them heavily, how do you actually implement it so that you actually are able to run this and get the proper context for them? First kind of option that we have is the idea of overriding it. You create one service and you essentially provide an implementation that overrides the original implementation on the server. As you can see here, we are basically providing a server cookie override, and this basically has two versions of it. It has the version that you're using on the browser, and then you have a server-only version that is overriding it, creating one implementation for the browser and one for the server. Basically, both implementing the same API, the same public API, and both kind of implementing it their own way. Now, if you work in a very large application, and they're just using cookie, that's a lot of places to go modifying this to actually generate kind of a facade that actually gets pulled in everywhere. Which is why there is another way. I'm not necessarily suggesting that this is the best way for everything, but it is quite an effective way to not have to modify all of these places that actually have that behavior and just kind of monkey patch it. I don't mean monkey patch it like globally speaking, as these are different renders, but go ahead and monkey patch the implementation that is already available of that window. So that instead of having just the document itself, you can go ahead and modify or add the ability to use a cookie there, and you can kind of choose how much of this you actually want to use. Of course, you don't always have the ability to do that. Like, clearly there are some cases where you download another library, something as common as Hammer.js, and guess what? Hammer.js has an immediately invoked function, and that is going to call the window object. And just by doing that, it means it's actually going to crash the process, throw an error, and you have a problem there. Because of that, unfortunately, like if you can avoid using that, it's definitely the best path. However, if you don't have a choice, you always have the ability to do like global monkey patching, right? Essentially, we can globally patch the global namespace and add properties that we'd be used to inside of the actual browser. Something like a window, a document, intersection observer, or any other piece. Just realize that these are going to be shared across context. And so therefore, it wouldn't really be safe to pull things from there. Anything you store or add to there will persist throughout all different renders and can potentially cause other larger issues. There's also kind of the final question on that. That is, like when you're doing the shimming mechanism, because essentially this is what it is. We are extending the platform with additional patches. Do you want to go ahead and implement your version of the API? Do you want to go ahead and grab the cookies from the request and go ahead and pass them through and somehow act in the same interface that you're using? Or maybe with the intersection observer, you just want to go ahead and stub it out. So anytime anyone calls it from a third-party library, it doesn't actually affect your server. It's just a blank call that happens in the background. This is kind of a decision that you have to make on each API and on each thing. But generally speaking, where possible, you actually want to use as little as that API as possible, as it's most likely going to add unnecessary complexity to it. And that's kind of it for the general context and runtime. The next part is about application stability. As I mentioned, the application is essentially running all on the same thread, and at a moment or another, we send back a response. All right? How do we know when it's ready? How do you actually know if the application is ready to be sent out to the user and is completely rendered in that? This isn't exactly the real code. This is kind of a simplified version of it, and it's very close to what we used to have before in the old Angular applications. And essentially what we do is we create the platform and we then go ahead, bootstrap the application, and wait until the application ref says that it has become stable. It is now at a stable visual point and is now completed, and nothing should be happening from there. Then we go ahead and render the internal parts, essentially serializing the application and then destroying the application so that it doesn't persist in the memory. This allows us to, at a moment in time, tell the application and the server itself that we're done. This application is now stable, and we're ready to send out an HTML for the user. Now, what actually constitutes this stability? Like, how do you know when an application is stable? And the first kind of obvious part is Zone.js. Zone.js is one of the main parts that will contribute to understanding this. And it is understanding when Zone.js is stable. The patching is a little different, and Node. Not going to say it's like massively different, but you essentially are going to be very concerned with timers and make sure that the set timeouts, set interval, and set immediates are actually properly cleaned up and not lasting like massive amounts of time, as they will prevent the completion of the actual render. But we, of course, have a lot more than that. We also have navigations. And of course, on a browser, you're going to have multiple different navigations that can happen, and on a server, you essentially are going to have like the initial navigation. So we're at least going to wait until the navigation event has completed successfully, and then we can consider it as actually, as that task is now completed. Of course, in the same way, we have API calls. Essentially, anything you're interacting with the network, you're essentially going to check that that is completed, as you probably don't want to render it if there is still a network request in progress. This would mean with HTTP client or also with using the new resource API. And finally, we also have like just pending task itself. There is a way to call a function on the server and saying, hey, I need to wait until this thing is going to be completed before we actually consider it as stable, as visually stable. So yes, we have zone, we have navigations, we have HTTP, and we have pending tasks. Actually, kind of not true. We have pending tasks. They're all pending tasks. They're all different ways of wrapping this. And so essentially, it is all kind of equivalent to just wrapping these internal APIs with just a task that says, until this is complete, we can't consider this application as ready. But maybe your application never becomes stable. Maybe a pending task never completes. Either you forgot to call the API because the interaction didn't complete the way you expected it to, or there is something else going on. For example, an infinite timer. Maybe you have an interval, something that just kind of keeps going. Maybe you have an RxJS operator that is actually throttling it and checking that in a certain period of time, only a certain amount of events actually occurred. Or maybe you're pulling for some data. You have a dynamic UI and you're updating a value, such as the price of something, and you keep updating that value over time, trying to make sure that it's kept up to date. And all of these things will cause an infinite render. This means the application will just continue until the network actually times out and the call is rejected. Which is why we also have a way to prevent this issue. And if you're dealing with large enough applications, there are many cases where this is going to happen, where somehow there is an additional configuration that changed and created an infinite timer or an infinite interval, and we can introduce this concept of a deadline. Like how long is the most you're allowed to wait before you just consider it as complete, whether that's successful or it fails. So, if you've been paying attention, you know that I'm kind of lying again. If you see this, you have this concept of a set timeout, which is going to prevent the completion again. So it takes a little bit more than that. You actually want to go ahead and make sure that that completion doesn't actually affect the render stability. So the deadline is essentially running outside of this context, and we wait until that actually is complete. And if the application is stable before, we just cancel the timer and no interaction is actually necessary. So how do we actually handle this like cancellation that we want to do, this render deadline? The first kind of option that we have is to go ahead and just delete the pending task. We can consider it done. We remove it. Like, this is pretty straightforward. Just telling the application, hey, we're done. Just call it a day. There is a problem with this. If you have, of course, like an interval that is preventing this from happening, what happens with that interval? Most likely, just going to keep going infinitely in the background. And if this is happening once per render, what happens to your server? Well, memory goes up, 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 and then it crashes. Of course, you can have a Kubernetes cluster in which essentially you're restarting the pods every time they crash and you have multiple pods. So it isn't a huge issue. However, you still have to actually deal with some of these issues and prevent them from actually continuously crashing your server. So what we can also do is go ahead and cancel the actual tasks. The easiest way to actually do that is take a look at what's happening inside of Zone.js and what caused these tasks to actually become unstable. So here we have an example in which we're basically checking through a plugin all the tasks that are actually running and that provoked Zone from becoming unstable. We essentially take all of these macro tasks, and on that deadline, we cancel them one by one. In the same case, it should prevent the actual pending task, should complete the pending task that was actually related to that and allow the application to become stable. In addition to that, you can see that I'm logging something. And that is because this plugin also allows you to identify the location of these APIs. Like, where is this timer being set? So you can see there in the bottom that is actually in this case set in app.ts on line 21. Of course, this kind of varies from application to application. In a very complex application, you might end up with a very large trace, a very large stack, and essentially making it very hard to read. And you might have to find other alternatives, such as actually patching the timer to identify these locations. But in most applications, they should work just fine. And this comes with a warning. If you're canceling the actual request, there's most likely something wrong. There is most likely a problem inside of your application that didn't complete it. Is this because a request didn't complete? Is this because something else happened inside of it that is preventing that from happening? Well, it's important to evaluate like in what conditions do you consider the applications to still be stable and how much cleanup still needs to happen after the fact. So you can actually decide like, is this successful or did this request fail? And finally, we have the beautiful topic of hydration. Fortunately for me, I don't have to talk too much about hydration. Michael actually did a wonderful talk, our very own Michael, about incremental hydration last year. If you're interested in watching the talk, you can go ahead and check it on this QR code. It is on YouTube and available for everyone. But just to give kind of a general recap of what this is, essentially in the original version of SSR, what we had is pretty straightforward. We deliver a document, and when the application would bootstrap, it would essentially delete that document, recreate another one in the background, and that's the one that would actually be hydrated or like created on your actual browser. But this is of course changed. With hydration itself, what is happening here is that we have one document and we reuse the HTML, essentially allowing us not to destroy it and not to like recreate the whole process, making this way more efficient. Of course, there's a lot more to it. There's also like the concept of like incremental hydration, where we do one piece at a time, an event replay. But there is kind of an additional point that I kind of want to mention about all of this, and it's where hydration becomes really important that works out as you would expect. And that is because of CLS. I told you that improves performance. Yes, it'll make your application much faster, but you might have additional issues that you didn't realize. You might have situations in which, for some reason, one of the buttons, one of the pieces was not actually rendered on the server. And that's going to go ahead and create a layout shift, and maybe you had a banner. User clicked on the wrong item. Essentially, it's important to actually consider what these effects can do. But thank God, or thank the Angular team, because they have created wonderful dev tools that actually allow us to debug these problems and actually take a deeper look into which pieces of it are actually broken and how do we actually fix one piece at a time. Essentially, inside of Angular DevTools, you can go ahead and download that plugin, and then you will have a tab for Angular where we can go ahead and take a look at that render tree. Inside of this render tree, you will see all of the different components that you have, and then you can see something on the side there. We have a hydration drop, I guess, and that hydration tells you all of the components and at what stage of hydration they're actually in. So you can actually see just by hovering it there, I can see that this is this main component over here, and the component has already hydrated. Now, this is the best case scenario. I could just hydrate it, everything worked exactly as expected, and there is no like major change there. There are also times where you don't expect that to hydrate. For example, here we have a component that was just deferred. This is a tooltip. We didn't actually want that to render on the server, which means it was just created on the client side. And by using defer, we didn't actually have to like work around whatever issues we would have there. So it didn't hydrate, but that's kind of what was expected. You also might have a situation where a component just never hydrates. For example, here we have a scroll adapter, which at that moment in time did not hydrate, which might be caused by something else inside of the application not quite matching up, or the DOM being different. Essentially, what we can see here is all of the different pieces that actually hydrated, and then the pieces that are still dehydrated inside of the application, or the pieces that were recreated only on that client. So the question kind of becomes, what causes these hydration breaks? Like, why would this actually not pair up? And the reason is pretty straightforward. The execution changed somehow. You didn't continue that render so that it was at the same state so it could just pick up from there, or you forgot to transfer some value. Essentially recalling an API that forced a completely different render, for example, adding a loading spinner and then recreating the actual widget, completely destroying that process. These are all kind of things that you have to think about as you implement SSR in these applications and how to persist those transitions. All of those things are kind of necessary, or are the necessary parts that you need to be able to implement properly SSR in especially dynamic applications. And there's a lot more that can go into it, a lot more different pieces that are kind of unexpected. However, that is it for today. And if you do have any more questions, please thank you for your time, and feel free to ping me or ask anytime on X.